Hello, AHR-160 refrigerant certification class. We're going to talk about compressors today. So there's a compressor up here on your screen that I want to call attention to real quick. This particular compressor is going to be a reciprocating compressor. We can see the cylinder heads here. Those are cylinder heads. We definitely know there's pistons underneath those if we know anything about a compressor. So this is a reciprocating model. Another thing I want to point out to you is the fact that it's got an open drive. So this runs off of an exterior electric motor, an electric motor that's not actually part of the compressor itself. And one of the troubles that we see with these kinds of systems is this rotating shaft, if it's allowed to set up anytime at all in a non-running state, such as maybe during the winter or sometime when the compressor just legitimately isn't running, this shaft seal will start to get hard and non-compliant and it's going to start leaking refrigerant out of it. So that's like the number one place that we see leaks on these compressors is around that shaft seal. Otherwise, there's a couple other features on this compressor that I want you to be aware of. You're used to working with residential equipment in our lab if this is not your first class that you're taking. So you're not used to seeing compressors like this, and you're not used to hearing the terminology of discharge valve or suction valve because our residential compressors just don't have that. They're just a hermetic shell inside of which there's a compressor. So what it's showing you here is the low side valve and the discharge valve. There's a couple of rules about these. Now on the low side valve, we're typically bringing in low temperature, low pressure, superheated vapor. So cold refrigerant vapor is what's coming in. That's going to act to cool the compressor. We definitely don't want to crank this compressor up when that valve is closed, because what it's going to do is it's going to pull a very, very, very quick vacuum underneath that. It's also going to cause our compressor just to heat up very quickly. So not a good idea there. Not going to cause imminent death of the compressor if for whatever reason we happen to crank it up and see that the suction valve's closed. We can shut it right back off with no harm to the system. Now the discharge valve is a whole nother story. This discharge valve over here, like I was saying, you do not want to crank this compressor up with that one closed. It will, and I mean will, ruin this compressor. Say if this is closed, this is a 4-cylinder compressor. So it's capable of pushing, let's say, 40 cc's of refrigerant for every stroke that it makes. So 40 cc's of vapor gets compressed for every stroke of a piston. If all four of these pistons make 4 strokes apiece while this valve is closed, then we're putting a quantity under that valve that probably could equivalent to about 4,000 or 5,000 pounds of pressure. And that's not good when this thing is trying to rotate and add to that pressure. So we never want to energize this with the discharge valve closed. We probably would break a connecting rod, probably force a cylinder through the side of the cylinder wall. Something catastrophic. It's not ever good when you crank up a compressor with the discharge valve closed. All right, so what comes out of our discharge valve here is high pressure, high temperature, highly superheated vapor. So it's very hot coming out, very cold coming in. And you might be thinking why that is. Well, anytime we compress something, what we're doing is taking the heat and stuffing it into a smaller space in addition to the substance itself. So when we're taking that refrigerant in as a vapor and we're squeezing it, all the heat that's in that refrigerant has to take up a smaller space. It's going to run up in temperature. It's going to run up in pressure. It's just a phenomenon called the heat of compression. Okay, so that happens. And that's one of the main functioning mechanisms of our compressor. It's one of the basic facts on which the compression cycle refrigeration system is built or designed. So the compressor is definitely the beating heart of the system. There's 5 different types of compressors. You can see those on the screen at the bottom. We've got the reciprocating, scroll, rotary, centrifugal, and screw. So let's talk about those for a second. The reciprocating, scroll, and rotary compressors, those are your residential type compressors. We see those a lot in hermetic compressors for residential air conditioning, for residential refrigeration. Now when we get up to these rebuildable machines, this is what you see in the commercial sector. Now this is a reciprocating compressor, but it's not the same type of reciprocating compressor that we would see in a residential situation. This one's a rebuildable. This is a serviceable model. It's not hermetically sealed. It's not welded shut. So different type of compressor here than what we're used to seeing in our lab. There again, Compressors vary in design, but they don't vary in pumping mechanism. There's only 5 of those. All right. You may be thinking what a centrifugal or a screw compressor is. Okay, centrifugal screw compressors. Those are in our low pressure systems that move a very large amount of vapor all at one time. So systems like chillers, things like that. That's when we see the the centrifugal and screw compressors. Only when we're moving large quantities of vapor. We're not really super compressing it. So that's a little bit of lesson about the compressor. Hope you enjoyed this video or at least learned something from it. And we'll see you in the next video.